Hi, I'm Catherine Sizemore. I'm a senior solutions architect at MariaDB. I have about 10 years of experience as a DBA, managing, supporting, architecting, building both cloud and on-prem databases. I'd like to start by thanking you for attending this open work session. I hope you've heard some interesting sessions so far and that this can be another tool in your toolkit. Our topic here is plug into analytics, connecting Columnstore to source databases with Spider Engine. Giving you kind of a high-level overview of what our session is all about today, we're going to start with a transactional database system. Let's build up a typical architecture of this. We start with a database or two, systems like MySQL, SQL Server, MariaDB, MariaDB Xpand. Hopefully you've got some kind of proxy server or load balancer in front of that, like MaxScale, which also has orchestration for high availability. So that's a really great tool. Then above that, you have an application layer running your CRM, ERP, POS, lots of three-letter acronyms. Maybe your website is there, right? Of course, you'll need some kind of user interface for either internal users or end users or customers to interface with this system. Now, this is your day-to-day business. You might have 10 different applications that look something like this, servicing different parts of your company. So as you grow, you'll find that beyond this transactional architecture, you need a data warehouse. You'll want a single system that houses your historical data, maybe your archive data, years and years of archive data, and consolidate those multiple systems and allow you to run some beefy analytical reports on it. This data warehouse is where we're going to house our analytical database, and MariaDB offers a very impressive analytical engine, Columnstore, for that purpose. Today, I'll show you how that Spider engine, which is just a plugin engine to that server, how that can help you plug in your transactional and analytical databases. So let's talk about how to feed your analytics with that Spider engine. Your transactional source database can actually be a number of different databases. MongoDB, Databricks, MariaDB Server, MariaDB Xpand, which is what our demo will go into, Microsoft SQL Server. It can be any of these things because Spider Engine just uses ODBC to connect to whatever database you're currently using. It's a plugin engine that just sits on MariaDB Server as an add-on and can link to your source database. For the demo today that I'll be doing, we'll be using the Columnstore engine and the MariaDB Xpand engine as our transactional source. So let's dive a little bit deeper into what distributed SQL Xpand is. MariaDB Xpand is distributed SQL. So it's a single logical database distributed across multiple nodes. And although the data is distributed, you can connect to any node in the system and access the data like it's a single monolithic database server, but with all the benefits of sharding. It also has all the benefits of NoSQL with its resilience, scalability, but Xpand is written from the ground up with MariaDB MySQL language that many understand. It's very easy to start interacting with the data, and it's ACID compliant. So these are two major features that NoSQL doesn't offer. Of course, you'll never have to worry about availability because it's inherently resilient, it's self-healing, and it's highly available. Xpand is purpose-built for scale. So let's look into some Xpand use cases so you can kind of see where it may fit in your environment. Xpand is designed for mission-critical, high write loads requiring strict consistency and scalability. Let's start with the global media or IoT use case. Now, our biggest user of Xpand is actually Samsung. Samsung uses Xpand to manage hundreds of millions of customers' access information to the Samsung cloud. With more than 2 billion smartphones sold, all Samsung Android phones rely on Xpand to manage user information, entitlements, and things like their billing data, their usage, their photos, etc. So as you can imagine, they have a very large workload with more than 230 million transactions per second. Another great example of Xpand is with gaming platforms, both gambling and social gaming, where consistency and accuracy for auditing purposes is extremely important. But they need the large scalability of many concurrent writes and users. The fintech world, investment firms, tax agencies, they look to Xpand for similar reasons. They're able to, like with certain tax company, they're able to scale when they need to during tax season and then reduce their print back down and reduce their overall spend with ease. Another great example of Xpand use case is the hospitality industry, with hotels, amusement parks, concert venues, maybe event ticket sellers. They have a great Xpand use case. For example, if you've been following the news, or maybe you have some fangirls in your family, you may have heard of a certain concert ticket seller who had a very large load when a very popular singer's concert became available. It crashed their systems. Let's just say that if that ticket vendor had been using Xpand, that whole event and handling of that spike in load would have gone a whole lot smoother for them. So now let's talk about our data warehouse and Columnstore, right? That analytical engine. Columnstore is a high-performance engine supporting a variety of analytical use cases. It has incredible analytical query speeds, and that's partly due to the overall architecture of being column-oriented, but it is still faster than other column-oriented analytical databases on the market. It's also a native MariaDB plugin engine, so you install the MariaDB server, and then you just download the Columnstore plugin and implement it in your system. So it's much easier to use than some other variations. It's got the MariaDB language, and it's simple to install. It's also got blazing fast data ingestion speeds, and this is with the tool CP import built into it. It's able to bypass the SQL layer completely and take flat files directly into the database backend. Finally, it has some extra additional features that allow it to be very hardware and cost efficient. You could put it on regular like EBS or hard drive storage, but a great feature it has is being able to put on object store, things like S3, where you can store massive amounts of data on very low cost storage options. Let's dig into a Columnstore use case so you kind of understand how it works in some of our customers' ecosystems. Like we discussed before, it's about observing your business, and this customer intelligently adapts as it's integrating all of that data. This customer is an online, large retail apparel company, and they're using Columnstore to be dynamically data-driven with their marketing. So they start with a MariaDB Columnstore cluster, with, of course, MariaDB Max Scale, our load balancer, proxy server orchestrator in front. They have some ERP systems, CRM systems, and whatnot, but that is tangential to what Columnstore is used for. What it's mostly used for is they have Google search, paid search data that comes in. They have keyword analysis that they're collecting, where users are clicking and what they are interested in there. And then they also collect user data, demographics, information about who these people are and what their preferences are. Finally, they also track their social ads, social media, where those ads are going and that sort. So that all gets funneled into a data stream, a Kafka data stream, which is then imported into the Columnstore cluster. There's also some other files that are dumped into CSVs that are lightning fast ingested with CP import into the Columnstore cluster. So this is coming multiple sources over a long period of time. ingesting that data, getting larger and larger so that they can provide very on-target marketing analysis, customer behavior analysis, and make sure that their advertising and marketing spend is really targeting what's going to make them the most money, what's going to be most beneficial and catch customer attention. And they're able to do that with some machine learning processes and some reports and BI tooling. So they're able to assess that with the data in Columnstore and feed it back into their marketing. So that's great for all of that flat file data and ingestion, but how do you bridge the gap between, you'll notice that ERP system isn't connected to Columnstore. How did they bridge that and pull in some more data without having to go through Kafka streams? We're able to bridge that gap with Spider. So how do we plug in the Spider engine? So we've got that MariaDB server running Columnstore. We've got the Spider engine table installed, and we're going to link that to our MariaDB Xpand in our demonstration later. So step one, install, enable Spider engine on your analytical server. And that can be done fairly simply. You can use your RPM repo, yum, or apt-get install MariaDB Spider Engine, and then just go into your MariaDB running instance and run install soname HA Spider. That can also be put into your config so that it starts up every time the MariaDB server starts up, but this is a quick way to get up and running. Next, you'll just create a Spider table with the ODBC connection to your source database. Once it's created, which takes microseconds, you can start running queries, and your application or wherever your queries are looking, it sees that table as a local table. So it doesn't know that it's pulling the data from that Xpand engine. So ways that you can use that Spider table now, you can create on-the-fly queries, join that source table that we've made with Spider on local tables. You can create a stored procedure to select data from that source and maybe insert it into Columnstore. You can also use ETL to pull the data from your target, maybe run some updates or analyze it, and then insert that data into Columnstore. So just a few ideas of how this can be effective in your environment. So let's take a quick look of what that looks like here. So in our demonstration, I will have the Xpand cluster, and that will actually just be a single Docker image to simulate that Xpand cluster. There'll be a MariaDB server, also a Docker image with Columnstore and Spider engine installed, and it will point to my Xpand cluster. Remember, we have max scale in front of almost all of our installations. So I'll create a Spider table with a very simple connection string. You can see here, I use the create table syntax, and then I list the same configuration, right? The create table structure will be the same as my source, but the difference here is I will create the table with engine equals Spider, and then in the comment section, I list the host. And here my host is XPD, that's the name of the Docker image on Xpand, the username, the password, the database, and the table name. So that will directly point at that Xpand cluster, database, and table. Now, all that's actually stored on this server is that connection info, that create table statement. All right, let's jump into the demo now. And as I alluded to before, this demonstration is going to use Xpand Docker image and MariaDB's Docker image. That's MariaDB server with Columnstore engine installed and Spider engine installed. So it's really just two pods that we'll be looking at. Down to our demonstration. You'll see on the left, I've got it titled Xpand Docker, and on the right, I have Columnstore Docker. This is just already in on the Xpand server and the Columnstore Docker image. Let's do show databases. All right, so you can see the BTS database is what we'll be using here. Okay, so On my source, I've already preloaded, and you'll see this later. There's a whole GitHub repo that will set this up for you. I've preloaded the BTS database with airlines, airport, and flights. On my Columnstore side, I've created the airlines CS. Now that's got the same syntax, the same table definition, except it's got the Columnstore engine running it. Okay, so that means it'll be stored in columns in Columnstore as opposed to rows like every other database engine would do. I'm also going to point out these spider tables are very similar. Here you can see create table, exactly the same as my source, with the engine spider, host XPD1, that points to here, database BTS, table airlines, and the connection information. So let's look at that. All right, so as you can see, I'm getting the same information, even though that spider table is just definitions. There's no actual data over there. Let me take a moment to illustrate that. So right now I've created an InnoDB table. That's basic transactional engine, right? There's nothing in it, but let's put some data in there. I'm just selecting from the BTS Airlines table spider, right, which is pointed at this expand table, and I'm inserting it into my new InnoDB table. All right, now let's back out of there and see what's actually happening on the back end. Because all 30 rows inserted as expected. So you can see here, I have 3 FRM files. First is my airline CS FRM, and I haven't put anything in there, that's still empty. I have the airlines InnoDB table that we just created, and the spider table with that FRM. And what FRM is, it's really your table definition, right? So what is this IBD table, and why is that the only one with one? Files are where our data is actually stored. So those 30 records are right here in airlines InnoDB.ibd. But you'll notice even though I'm pulling data out of spider table, there's no actual data stored here. So this is a great illustration of I just have that table definition locally, but when I select from it, it's pulling the data over from that source. All right, next let's try and take advantage of that Columnstore table. Let's put data into Columnstore. And there you see, now I've got data in Columnstore already. Now it's stored on disk in the Columnstore engine, which means that instead of those rows, which the InnoDB engine will do, it's got those columns. So it's much, much more efficient for large data sets and analytical queries. All the tables I've shown you with Spider Engine have explicitly shown the connection info. Now, you don't really want that accessible, especially in a production environment. So let's see how best practice is to do that in production. My other 2 tables, I use a different method for connection string. Here you can see the create table for airport spider. I list the engine equals Spider, and then I do server expand one, database name and table name. So the rest of the connection info is not there. Let me show you how I created server expand one. And I'll need to jump over to the Docker host with all that startup information embedded in it. So we looked at airline Spider with the explicit. Then after that, I create server expand one with foreign data wrapper MariaDB, and it has the same connection info that I was putting directly into the table comment. So then all tables after that, I can use server expand one instead of listing that connection string info. And you can see there's no way for me to pull that information back out, so it's quite secure. All right, now let's just double check. There we have it. All my counts between Xpand and Columnstore are now the same. All right, so to wrap up, I want to just show some of the Columnstore performance now that we've got the data over to that side. Now, BTS data, you can see we've been using flights, airports, airlines. This is information about flight information in the US for several years. This first query here, oh, that ran so fast I didn't even get to explain it. This first query here is looking at the year 2020, flight summary information, counts, market share, what the percentage of cancellations and diverted flights were by airline. And it went so fast. In less than a second, it consolidated all of that information. And you can see these are actually row counts. Southwest Airlines, we have over 961,000 records just in 2020 that it's looking at. My next query that I'm going to show off. This is summarizing the airline delays grouped by airline, by the type of delay, and by year. And it actually includes 3 union alls, which if you've tried to do that in transactional systems, you know could get pretty ugly, especially with big tables like this. And there you go, in 2.5 seconds on my tiny little Docker image, I'm able to pull 468 rows of consolidated data. All right, so there's just one more query I want to show. And this one is showing me in the year 2020, delays in the state of California, okay? So here I've got all the different airlines by airport, the average delay for that airport. And it returned in less than 0.6 seconds. So this was all with Columnstore tables, right? And all of these queries so far have interacted with Columnstore tables. But what if I don't want to have to copy all of that data over to Columnstore? What if I only want my biggest tables there locally? So my biggest table here is flight CS. What happens if we join on Spider tables instead? Using that cross-engine join. Let's use the same query. You see I've swapped out that CS for SPDR. Bam. And still in 0.6 seconds, I'm able to return the same data set using Columnstore and Spider instead of having all of those records over in Columnstore. Now the demo's complete. You can really see how this architecture can be a real advantage, giving you the power of Columnstore and that analytical engine with just a quick hop with Spider engine, bridging that gap. Now, this demo that I just went through is actually available on GitHub under my MariaDB ksizemore account. Here is the link to it. It has all of the tables, queries, the Docker compose files to spin up the Xpand Docker image, the Columnstore Docker image, and populate all of those data and tables as we walked through it, right? So you will only have to run the insert scripts to move the tables across with Spider, as I showed in this demo. So what are your next steps? Now that I've gone through all of this, you're totally sold. What do you do to get more information? Well, I do recommend attending the next session. It's Expand Your Data Possibilities and Pipeline with MariaDB Expand and Click Data Integration. That's if you want to go more into what you can do with Expand, and Click is one of our vendors, how you can maybe get up and running with Expand quickly so you can take advantage of that scaling. I also recommend you watch the following session on demand, which will be available tomorrow. It's called Using MariaDB Columnstore with Power BI for Visualization and Reporting. That's a really great one led by our product manager for Columnstore. Can show you we're Power BI certified, how you can take advantage of analytics in Columnstore and Power BI. Again, that's the link to the demo again. And I also recommend, if you like what you've seen, just get started and try it out today. You can do that on SkySQL. Both Columnstore and Xpand are analytics and distributed SQL options in SkySQL. And if you get started today, you can use the $500 free credit to get testing and seeing how these things perform in SkySQL. There's my information. I welcome you to connect with me on LinkedIn. Shoot me an email if you have any questions, if you want to dig more into it. I more than welcome your feedback and engage in a conversation with you about how maybe you can implement this in your own environment.